All right, section 3 of chapter 5 is now going to do something that we've done probably about 5 times this year already. We are going to be graphing these. Okay? So, first and foremost, the first two things I'm going to share with you are the parent functions for these. The first one is the square root of x. When you're graphing that, again, I'm assuming you're probably just going to put it in your graphing calculator anyway. But just so that you guys know what the parent function looks like, is it starts at 0 and goes up like that. That's what the parent function would look like, something in that similar fashion. It starts at 0. It does not go on forever down below. It just starts at 0. And the reason for that is because what is the square root of 0? 0. So if I put in 0 for x, I get 0 out for y, and that's why it starts there. What if I put a negative in there? Can you square root a negative? No, not and be real. It'd have to be imaginary, and that's not possible. So therefore, that's the parent. Some of the things that we're going to ask you to do is we're going to ask you to graph it. We're also going to ask you to identify the domain and range. It's been a while since we've talked about that. Domain is the x values that work, and the range is the y values that work. So, when I'm coming down this thing right here, nothing's happening, nothing's happening, nothing's happening, nothing's happening. Oh, I get right here to the origin, now something happens. What's the lowest number you can put into this one? 0. So it starts at 0, and because the domain is equal to 0, I have a bracket if I'm going to use interval notation. And where does it go on to the right? Forever. So I would have an infinity. That is the same thing as you guys putting this. X is greater than or equal to 0. Those are identical. So whichever way you want to write it, that's your choice. What?
Why does one have bracket and one have
Parentheses means not equal to, and bracket means equal to. So a parenthesis is always going to be on an infinity symbol, Tamara, because can you equal infinity? No, infinity isn't even a number. It's a concept. It means that we know numbers go on forever. We're just never going to get to the end. That's why it's never a bracket. A bracket means I can actually physically stand on it. Okay? Now, what is the range? Remember, goes from floor to ceiling. So for this particular thing, as we're coming up from the bottom, nothing's happening, nothing's happening, nothing's happening. Oh, right here. Where does it start? At the origin. And where does it go? Up. Forever. It looks like they'll level off, but realistically, the further out to the right you go, the higher it will get. It will continue to climb. It's just going to take a long time to get there. So what's the range? Also 0 to infinity. Or, in the range's case, y is greater than or equal to 0. When you are dealing with range, you're dealing with the y coordinates. And when you have the domain, you're dealing with the x coordinates. Okay? That's the domain and range for this particular parent. Is everybody okay with that? Mm-hmm. The second parent that you're going to have is when we have cube root. There's only 2 parents you're going to have today. Okay? Or in this chapter. Bless you. Okay? This is the other parent that you're going to have. It's very similar. However, there is a catch to this one. Can you cube root negatives? Yes, you can. You cannot square root negatives because remember you're looking for what times what gives you a negative, and that's not possible. But cube root, negative times the negative times the negative would be a negative, and that's okay to have it. So you can have negatives. This parent looks like this. Okay? That's what that parent looks like for the cube root function. Now, what's the domain? Bless you. What's the range? Where does the domain go? How about to the left? Where does it go? Forever. How about to the right? Forever. Now, the way that you list that out, if you're going to do it in interval notation, is forever to the left is negative infinity. And forever to the right is positive infinity. There's no stopping points along the way. Everything's fair game. If you wanted to write it out the other way, all real numbers. Everything is fair games. Okay? What about the range? Same thing. It goes all the way down and it goes all the way up. So negative infinity to positive infinity. Or all real numbers. There's not really any of them. Okay, that's another way of writing all real numbers, is that fancy looking R. Looks like a capital R with two lines for that one. Okay? Now, as far as graphing goes, how are you, for the most part, going to graph most of these? With my calculator. How do you type in cube root in your calculator? Math. Okay? Now, when you hit the math button on your calculator, there's a couple things there. Option 5 allows you to put in any number inside the crack. Option 4 actually is specific to cube root. Okay? Option 4 on the graphing calculator, once you hit math, is the cube root one. So you don't even have to put the number first and then put the option 5. You can just do option 4 and it's already got it loaded in there preset. Okay? Now, what if they do this to you? What if they ask you to graph f of x equals 1/4 x? State the domain and range also. So they're going to ask you to do 2 or 3 things. Graph it, state the domain and range. How are you going to graph the square root of 1/4 x? Okay? If you're going to use your calculator to graph it, you would type square root, and then it automatically comes up with a parenthesis. Now, me personally, here's how I would do this on my calculator, is I would put another parenthesis, 1 divided by 4, close it, x, close it. If you close it too soon, the x won't be under there, and it will look like a line rather than a curve. Okay? So, another thing that is also going to come out in the second example is it was multiplied on the inside. What is multiplication on the inside? Horizontal stretch or shrink. When it's a fraction on the inside, horizontal stretch or shrink, it is a stretch by 4 horizontally. So did it look a little bit more elongated? My guess, did it look like this? Real flat? Okay. What's the domain? 0 to infinity. What's the range? 0 to infinity. It didn't move left or right any, did it? Did it move up or down any? No, it didn't. So that doesn't change that fact. So the domain, and again, you know how I like to write it in interval notation. And the range was also negative infinity to 0. Okay? On the second half of your assignment today, guess what you're going to have to do? You're going to have to tell me what transformation took place. None of that's new. How many times have we done transformations? A lot. What does an adding on the outside mean? Shift up. What does a subtraction on the outside mean? Down. What does a multiplication by a whole number on the outside mean? Vertical stretch. What is a multiplied by a fraction on the outside? Vertical shrink. What does a negative on the outside do?
Reflection over the X.
Reflection over the x. What's the negative on the inside?
Reflection over the Y.
Reflection over the y. What is an adding on the inside? Left. What is a minus on the inside?
Right.
Right? What is a multiply by a whole number on the inside?
Horizontal shrink.
Horizontal shrink by
A whole number.
the reciprocal.
Oh, by reciprocal.
What is a multiply on the inside by a fraction?
Horizontal.
Horizontal stretch by
It's
the reciprocal. So when I report the transformation that took place, that would be a horizontal stretch by 4. Okay? That's what you have to do for the second half of your assignment. Lots of graphing. Okay? You're going to have to graph it on the first ones and tell me the domain and range. Second ones, you're going to have to tell me what transformation took place and graph it. Is that any different than what we've been doing in previous chapters? No. The only difference is new parents. That is a square root parent because it just starts here and goes on. Cube root parent looks more like an S curve. Okay? Are you guys okay with that?
Yes.
We've done so many of them, I don't know if we need to do a whole lot more. Okay? So on page 256 to 257.